And there we go. I'm back. I told you I'd be interrupted. But a disadvantage of using a map is the idea that maps are often, they often show distortion. Okay. So maybe the next question you have is, well, what exactly is map distortion? Maps of the entire world, which we see ones of the United States or the world, they're great, but they're not 100% accurate. And the reason is because it's impossible to take a spherical object and boil it down to a rectangle, right? The cover of this is not going to end up being a rectangle or a square or any sort of neat shape, right? Think about when you peel a grapefruit or a clementine or an orange. The peel, when you have it, sitting on the paper towel in front of you, it's not going to look like a square or a rectangle or even a circle. It's going to look like some sort of mishmash of shapes, but that's what's necessary in order to cover the sphere. So in order to avoid that, we sometimes use projections that show distortion. So an example of this would be the famous one called the Mercator Projection. Now, people like the Mercator Projection because the lines of longitude and the lines of latitude are all straight. However, by doing that, it makes things distorted. For example, Alaska, anything towards the poles gets much larger. All right, Greenland and South America in real life, Greenland is about 1/8 the size of South America, but because of the distortion on the projection, they look about the same size. In real life, Africa is about 20% larger than North America, but because of the distortion of the Mercator projection, it actually looks like North America is larger. This island way up here called Ellesmere Island in Canada is about 1/45 the size of Australia. But you can actually see that on the Mercator projection, they appear similar in size. So there's distortions all over the place with regard to Mercator projection. But it's hard to be too hard on the map makers because what they're trying to do is impossible. They're trying to take something that is shaped like this and pretend that what covers it is a rectangle, which cannot be done. So another projection would be what we talked about, an orange peel, right? So if you actually peeled an orange, your peel might actually be shaped like this. But is this something that we're actually going to see in classrooms or analysis? Well, perhaps. But again, there's going to be some distortion because we know in real life there's not some sort of huge crack in the North Atlantic or in the South Atlantic or down here in the Indian Ocean. Yes, the land areas might not be distorted, but we are left with these large gaps that we see there. The last thing I want to talk about with maps is the importance of scale. So here we see on our left, we have a map of California, which is our third largest state, and then New Hampshire, where we live, but is one of our smallest states. So if you just look at the map, you might be like, well, they're roughly the same size, right? They take up basically the same amount of size on my screen, but you have to look at the scale. So right here is the scale for this map of California, and right here is the scale. So on my screen, at least with my laptop, it looks like that about every half inch is about 150 miles. That's for California, a much larger state. But with New Hampshire, every half inch roughly equals roughly half inch equals 35 miles. So you can see that whenever you're looking at a map, make sure you pay attention to the scale so you know exactly how precise the map is being. All right. Usually, the smaller the scale, meaning that 1 inch equals 2 miles, that means it's more precise than some other maps that we have. So that's one last thing to pay attention to. All right. So I do have some questions for you, which I would like you to answer by Wednesday, which I'll be posting my next video. And you can see them here. Please feel free to type the answers right into the Google Slides that we have here. So number one, what do globes and maps have in common? Your answer can be typed in right here. Number two, what are two examples of the Mercator projection offering a distorted image of the Earth? Number three, using the maps and scales. So that one, what we just talked about. And for that, please make it a rough estimate. Okay, you don't necessarily need to get your ruler up to the screen. And number four, finally, if globes offer greater accuracy, why don't people have them in their cars for when they travel? All right, so answer those. I'll probably post a video tomorrow just talking about sort of the overview of the class. But these are not due until Wednesday morning. All right, everybody. Hopefully this went well. And like I said, with regard to the video, I'll try to work out that error. Have a nice day.